Timer, like no timer. Really? Yeah, because timer lives in Russell. Yeah, this gotta be there. The other thing, right? This is the coolest guy. He's like, he's the guy you want to go over for like 14. Yeah. Friday.
We're going to, we worked through the odds in class on Friday. We'll work through the evens in class just to make sure we still remember our assessment. We'll start 10.05, which now is going to be solving log equation. And then from there, we're just going to do a lot of review for the remainder of the week. Okay. All right. So, page 13.
Thursday and Friday.
Yeah, Friday, Thursday and Friday, we do the same thing. Okay. Today, we're gonna finish this up, start the next section. Okay. So solving, exponential equations. Starting with number 2. Okay, so our goal is to try to figure out a way, to get the bases to match. If the bases can match, we can remove them and then just focus on the exponents. And if you're deciding which one should I change, it's easier to change from something from larger to smaller. So looks like that 3/4, we can't make that any smaller, but that 9/16, we can do something with it. So how else can you represent 9/16? Yeah, so 3 squared over 4 squared, or in other words, 3/4 quantity squared. You're right, 3 squared over 4 squared, but if I just want to make it look like the base on the right side, 3/4 quantity squared, the same thing as 9/16. And if I can get the bases to match, I can remove the bases and I can set the exponents equal to each other. So once you do this, we can distribute the 2 through, set it equal to 5x plus 4, and then the parentheses base portion can just drop out. Okay, try that. Yeah, anytime if you feel like there's not enough room on your sheet, feel free to grab the scratch sheet, work through your problem. Okay, so 3/4 drops out. I can distribute the 2 through. All correct. Yeah. For some of these, yes. Okay, let's look at number 4. So with number 4, what we want to do is eventually we see that look at where the x is located. The x is located in the exponent, so eventually you're gonna have to involve log or logs or natural logs to bring that x down. But before we do that, let's see if we can clean up as much as we can. We want to clean up our equation to the most simplest form before we bring in the idea of logs. So there's some things we can do here. We can combine the 1 and 3.4 together. Get that 1 over to the other side. Let's get that 8 to the x as cleanly isolated as possible. So we want to find a way to bring that x to a better location. So now we can take a log on both sides. You can do natural log or you can do log. Your calculator can handle both. So either one is fine. So I think I just did log of both sides. Your calculator can handle log. If you don't see a base, it's understood as base 10. We use log base 10 so much, we just leave out the 10 and just say log. Now that we have log of both sides, where can that x go? In front, right? So that's the whole benefit of logs is that exponent can come down in front, and we haven't changed the overall value, but we have made the equation easier to work with. Because now we can divide, right? Before that x is sitting in a place where, we don't have a lot of operations to work with, but now that x has come down in front, we divide both sides by log 8. Make your calculator find that decimal value for you. Now, if you did not have your calculator, then this is as far as I would expect you to go. Number 6, you're trying to solve for x. X is sitting in that exponent, but we can do some things first, right? Before we bring in the idea of logs and natural logs, we can do first. Yeah, let's get that left side a little bit cleaner, get it a little bit reduced so that we can work with logs. So divide both sides by 2.5. I can bring in log. Whenever I see E, I like to use natural log because natural log and E have a way of reducing a little bit cleaner. But I mean, log is fine as well. You can work log in, just more buttons to press, but it's not any harder. Bring the whole x plus 4 down in front. Natural log of E is equal to 1. So that can go away once that x plus 4 comes down. Now you're just making your calculator do the work for you. Decimal value, 5.6.
Like, then the calculator natural log of 5.6 minus 4.
Yeah. Well, I would be safe. I'll put that's like 5.6. Hit enter, get a decimal value, and then subtract 4.
Okay, oh, that's what I thought.
Yeah. You want to make sure that the minus 4 is not inside that natural log. So sometimes the calculator will may think that it's part of natural log. So I like hit enter, or you can close it with parentheses. Number 7, number 8. If the bases look like they can match, we can get the base to match. But here, 3 and 7, it's a little bit harder to get those bases to match. So we can still work our way around it. We can just go ahead and take log of both sides. If you don't see a nice clean relationship between the two bases, you can take a log of both sides. Just go ahead and try to bring the exponent down. Now, once that 2x plus 1 comes down and if x plus 3 comes down, we have to do something with that log 7 to distribute. So as a precaution here, put a parentheses around the 2x plus 1 and x plus 3 so that when it comes down, you're reminded that, yes, you want to distribute, and the log 7 is going to see everything inside the parentheses. Okay, distribute the log 7 through.
Right? Once you distribute log 7 through, then you know you have 4 individual terms. You can kind of move around. The whole idea is to solve for x. So let's move these terms around in a way where the terms that have x's can be grouped together on the left side. Terms without x's can go on the other side. And the whole purpose here is to factor the x out so that we can algebraically get that
Also,
x
you
by
you
itself.
expand it like we've been doing. A little bit.
Well, the problem here is that there's nothing that we can expand because the 2x is outside of log 7. Now, if I had log of, 7x, then we can expand into log of 7 plus log of x. So if we want to expand, it's got to be inside the log before we can expand.
Okay.
Yeah, this 2x is not inside the log 7, so can't do anything with that in terms of a log property.
Also, you just distribute it
What do you mean?
like the logs, you just distribute it into the parentheses.
Well, we're factoring the x out. So once the x comes out, what's left over is the 2 log 7 and minus log 3. So we're not distributing anything, we're just trying to get that x out by itself. And now that the parentheses is separated from the x, divide that over, and now you can get x by itself. But really, yeah, we haven't really used any log properties here. There's not any log properties to involve, except for the fact that the exponents come down. That's the only log property that really is within this problem. Yeah.
Can you explain just the process of, which terms go on the numerator and denominator?
Right, so, it's like if I had x times 3 is equal to 5, we divide both sides by 3. So whatever's on the left side is gonna move over to the right, it's gonna end up in the denominator.
Okay, so then
So-
divided, yeah.
Right, so this 2 log 7 minus log 3 is what goes below. And
Thank you.
yeah, it looks similar, but just imagine that as just 3 pieces and you're just trying to divide that piece connected to the x to the denominator on the other side. And now the rest is just calculator, getting it down to a decimal value. Okay, number 10, hopefully we can see a little bit more of this so that we can be able to recognize this as a factoring problem. And there's an x squared, there's an x, and there's a constant there, so yeah, maybe a little bit better is to let y equal to e to the x, just so that we can get kind of see an easier factoring problem in front of you. So if I make that replacement, this feels, I mean, we can factor without making the substitution, but I think most students find it a little bit easier to see this factoring here. So e to the 2x, think of e to the 2x as the same thing as e to the x squared. So that's where that y squared is coming from, but we can kind of recognize it as, oh, that's degree 2, degree 1, the constant. And now we can focus on the factoring, right? Multiplies to be 56, adds it to be negative 15. Multiples of 56 are 7 and 8. So negative 7 and negative 8 will do the trick. And then once you get it in factor form, let's bring back our original variables, right? Because our true variable is x. We just use y temporarily if it helps to get through that factoring step. And now we just focus on the two sets of parentheses and solving for e to the x separately within each equation. So e to the x equals 7, e to the x equals 8. These are two separate processes. We know that we'll go ahead and take natural log of both sides, because anytime your variable is stuck in the exponent, you want to find a way to bring it down, and log or natural log is going to be the most efficient way.
This one has multiple solutions.
Right?
This one has multiple solutions.
That's right. This has two solutions, right? I left my answer as exact value, natural log of 7, but you could put that in the calculator and get a decimal value as well. But natural log of 7 just feels more exact value, or natural log of 8. So there's two solutions here. Yeah.
Did you say there's gonna be a calculator on the test?
I'm gonna say yes for now, and I still need to confirm, but yeah. Okay, number 12. All right, 12 looks like a messy problem. Do we see a way that we can maybe quickly get rid of that denominator? Is there something? Yeah, so I'd like to cross multiply. If I see a fraction, or if I see something that could be written as a fraction equal to a fraction, I think we just have an easier time working with something if we don't have to look at the denominator portion. So if I can just cross multiply, get everything up to the numerator level. Now this feels a little bit easier, right? Okay, so what if I just distribute that 300 through, and then you're right. Yeah, let's do that. That's probably a little cleaner there. Let's go ahead and divide both sides by 300, and then I can kind of piece by piece move that 1 and 3 eventually away from that e. So ultimately you want to get that e to the negative 2x by itself, so they can bring in that natural log. So little by little, we want to try to move things away from that exponential portion. Yeah, so I think I worked it a different way. Let me do the way that you guys mentioned, dividing both sides. Yeah, let me show the steps that you guys said. One-third divided by 3 is same thing as 1 times 1/3, so it gives me 1/9. So now that that e to the negative x is by itself, let's go ahead and take the natural log of both sides. Because our ultimate goal is to try to get that x by itself.
Let's get rid of the -2 with the 30e -2x. Oh, yeah.
Oh, sorry, I lost it, didn't I? Sorry about that, I lost it.
Can you bring the negative up to the numerator? Or is,
It doesn't matter. A negative can be in the numerator or denominator. It just can't be in both.
Okay.
You pick one, doesn't matter where. But usually, yeah, usually I have to put negative in the numerator just so I don't lose track of it. Makes it easier for it to stand out. Let's see, I messed up this. So what I did was I divided both sides by 3, which is the same thing as multiplied by 1/3. So I got that 1/9 here. So then I take the natural log of both sides. That -2x comes down,
oh, yeah, you got it.
and I divide by -2. So what? So the 1/9 is inside natural log, but the 2 is outside of it.
You just put a negative in the numerator, so it's very change.
1.2.
Well, what happened was natural log of 1/9 is producing a negative value and then another negative in front. So the two negatives gives me a positive. Yeah, we haven't talked about the graphing portion of it, so no, I don't, yeah, right now we don't really, may not know exactly, what that natural log of 1/9 is looking like in terms of why, when it's not going positive, when's it negative, when's it undefined. We'll get a much more visual understanding of natural logs and logs on Friday. Okay, I want us to get started with 10.04. So after this section, sorry, 10.05, after this section, we'll do a lot of review for the rest of the week mainly. Okay. So it depends on the problem. Sometimes we want to take the log of both sides to bring the exponent down. Sometimes though, your problem is stuck in log form and you want to get it into exponential form to make it easier. So really depends on the problem. Sometimes it's easier to get from to work your problem out in terms of exponential form. Sometimes it's better, easier to get your problem solved when it's in log form. So the opposite of taking log of both sides is to exponentiate both sides. I'll show you two different ways to do that. This can be used to cancel a log from one or more sides of the equation. To do this, make each side of the equation exponents of the value. Okay, I'll let you guys decide to see which way you feel is easier to work with. I presented it two different ways, and I think sometimes students prefer one way or the other, but I can work it out both ways. So also the arguments of the logarithm must be positive. So we need to check for extraneous solutions. So if the x that we're solving for is inside a log expression, we do have to, after we find our solution set, we have to make sure that we test it out, because if your X value is causing your original equation to produce something undefined, we have to make sure we remove it. Okay, so let's look at example 1 here. I want to solve for the equation -3 natural log of x equals -24. Now, look at where x is located. I want you to understand that x is inside the natural log. So it's different than previous problems where the x is stuck in the exponent. Here, stuck inside natural log. So we can't just divide both sides by 3 natural log. And so natural log is it's connected to that x. So x stuck inside natural log. But what we can do is, let's get that natural log of x by itself first. So I can divide both sides by -3 just to get some of cleanup going here. Okay, natural log of x equals 8. Okay. Now, we can't do this. We can't divide both sides by natural log because natural log is not a standalone term. The x is within that natural log. So what we could do is, let's make it a little bit easier to see what's really going on here. Natural log is another way of saying what? Log base e. So sometimes seeing that base, I think is helpful because you know ultimately your base is what is it's kind of like your foundation here. So how can I convert this into exponential form to release that x into a better spot?
E to the 8.
Yes, e to the 8 equals x. So I've been presenting it this way where students just convert into exponential form. Okay, and I find that is clean. But here's another way that you can do it. If I had log base e of x equals 8, another way that they're mentioning is I can exponentiate both sides. What they mean by that is they raise both sides with e as the base. And e log e will cancel each other out. The x drops down, and you're left with x equals e to the 8th. So either way works. But if you can see, okay, base raised to the exponent equals my value. Yeah, so we can kind of play around with both ways and see which one sticks for you guys. Okay, so look at number 2. We want to solve for x, but x is stuck inside the log. Let's do as much as we can to get that log expression by itself, and then we can figure out how can I get to that x.
Can you subtract 3 from the 4?
Well, the problem is that the 3 is stuck to that log, so we can't quite do 4 minus 3. But what we can do is we can piece by piece move things to the other side of the equation, away from that log 5x. So what can we move first?
16 divided by 4.
16 minus 4. That's right. We will divide by -3 because 3 is being multiplied, but that 4 is by itself. We'll subtract 4 first. Okay, what's next?
-3 divided.
Okay, divide by -3. So this is different than previous problems, right? We don't want to take log of both sides because it's already log and there's no exponent that we need to bring down. We have to get to that x that's stuck inside log. We want to find a way to get that log to be, get that 5x out from under that log expression. So it helps if we can see the base. What's the base in this problem? 10, right? It's hidden, but if you don't see a base there, it's understood 10. So can I get this in the exponential form now? 10 to the -4 equals 5x. So now this feels a little bit cleaner, right? Okay, I can now, do some division here just to get that x by itself. So divide both sides by 5. There's my answer. I'm just gonna swap places. It's maybe visually it's easier to have that x on the left side, but
We just simplify it, so it's x equals 2 to -4, which you evaluate that to -4, so it's an exact number.
well, yes. What I would do is maybe to clean this up in your calculator, you can also bring that 10 down because it's easier to think in terms of a positive exponent. So I can bring that 10 down and make it 5 times 10 to the 4th. Okay, so either leave it in that form or we can get it down to an even a full number. So if you plug that in the calculator, 10 to the 4th is 10,000 times 5 would be 50,000. So all number 50,000.
Like getting x equals 2 to the power of -4 and do like 1.
That too. Okay, so the problem is that the 10 and 5 are not compatible. Because the 10 is stuck in -4. Okay, we can't do 10 divided by 5 is 2. Now, we could do it if it was this. Yeah, and if I can take that -4 out, then that's fair game. Then I can do 10 divided by 5. But this is, yeah, this is stuck to the exponent. We got to do order of operations if we want to combine it, right? Exponent needs to be resolved first before any division things can happen.
Is that?
Yeah,
Plug that into the calculator.
if it's exact, yes. Yeah. Okay, let's take a look at number 3. Okay, log base 3 of x minus 1 equals -2. We really can't move anything around. Everything is kind of stuck in this form. Normally, we would try to divide, subtract, clean everything up, but this is as clean as we can get. I want to solve for x. X is stuck inside the log. So let's just go ahead and get into a different form so that we can kind of see this problem in a different perspective. What can we do?
3 over 3 to the power of -2 equals x minus 1.
Good. Oh, guys, something that I've been neglecting to do, what I should have been doing is testing these solutions with the original problem. I should be able to insert e to the 8 and make sure that it's log of a positive number. But I've been kind of skipping that step because if I see a positive number, chances are I'm not going to have any issues. But when I see a negative number, I really need to be careful and plug in because sometimes a negative solution may cause issues with the original expression. So I can't have log or natural log of a negative value. But here, after -2 equals x, so x minus 1, 3 to -2 is really 3 squared in the denominator, which is really 1/9. So if I add 1 to both sides, 1/9 plus 1 is 10/9. I plug 10/9 in for x. I'm not going to get any issues because 10/9 minus 1 is still positive. Log base 3 of a positive number is fine. I just can't have log base 3 of a negative value.
As long as it was negative value, it's like no solution.
That's right. If there's negative value, there's no solution. If there's multiple solutions, if there's multiple solutions, one is negative, the other is positive. The negative most likely will be removed, and the positive is.
So the positive would just be.
But we should be testing all of our solutions. Sometimes it's possible where we get no solution because none of the solutions fit back into the original equation. Now, number 4, what do you notice about this project?
Squaring the.
They both sides have what?
The same base.
The same base or same log of the same base, which is nice because that will allow us, remember, anything we do to one side, we can do to the other side, same idea. Anything we remove from one side, if we remove the same thing from the other side, this feels like an easier problem.
You get after. Like the x squared minus 4 on square. So.
I would if I saw a 0 on this side.
Okay.
I think it's easier if we just combine like terms and then see where that leads. So the 4 and 21 can combine to be what? 25. Okay, how would you solve for x square root? What happens when you take the square root of an equation?
Plus or minus.
Good, plus or minus. So x is equal to 5 and x equals.
It's only the positive numbers.
Well, here's the thing is that the 5 is definitely fine, right? 5 squared minus 4 is 21. -5, is this going to be okay?
No.
Well, if I plug -5,
No, it's squared.
It's squared, yeah, so in this case, this is fine, because, negative 5 squared, let me see. Yeah, this one's fine. Negative 5 squared is 25 minus 4, that's fine. That parentheses is not going to turn into a negative expression, negative value. Okay, let's just do, I want us to do 4 more. I want us to get a little bit more practice with this so that tomorrow we can jump in directly into just practicing these problems. Okay. Now, these are a little bit different. I'll walk you through some of these here. Now, first off, what do you notice about both sides here?
Same base.
Same base, but the problem is that I can't just drop the log base 7 because I can't just make the 3 and the x to say 3x. So I want it to be log base 7, just like how log base 2 is. But if there's any coefficients, I have to find a way to put this in a different place. So can you think of a different place I can put that 3?
Log 7 x center.
Good. That 3 can come up to the top. If I bring that up to the top, I can get the log base 7 to be clean. We took care of that hanging coefficient. And now log base 7 equals log base 7. Now we're good. X cubed equals 64. All right, solve for x. I'll take the.
Only the positive works.
Well, here's the thing. If you take the cube roots, is there a plus or minus?
Oh, no, there isn't.
Yeah, only plus or minus for even roots. So we shouldn't worry about a positive 4. 4 is fine. No issues there. Okay. Number 6. What's nice about both sides?
Same base.
Same base, but I need a one-to-one relationship here. There's too many log base 2s here. We can't, but there is a property that we can. Is there a condensing property that's available to us?
Yeah.
Years.
Right, there's a quotient property, right? Log of A minus log of B is equal to log of A over B, yep. Okay, so now it's clean, right? There's no coefficients in front. We can just remove log base 2 from both sides and just focus on 5 equals to 10 over x minus 4. We can cross multiply, solve for x. Okay, I'll distribute that 10 through, distribute that 5 through. Okay, do a real quick check here. Is 6 going to cause any issues? No, it's not going to force any expression inside log to be negative, so we're good. X equals 6. Okay, number 7. It's nice. Everything is log base 4, but I need a one-to-one relationship here. What can I do with that left side? Condense. Good. So this is plus here, right? So log of A plus log of B is equal to log of A times B. Clean. There's no coefficients. Sorry, I dropped the log base 4 here. Okay, log base 4 removes. Let's go ahead and there's a lot of x's here. Really, we really have to resolve the parentheses. This could end up being a factoring problem here. Okay, I see x squared. I see degree 1. I see a constant. Let's just bring everything over to the left side. It's probably going to end up being a factoring problem. I'll subtract 6x to the left. I'll add 18 to the left.
We want the X to be positive though.
I just want the x squared to be positive. I don't, everything else, I don't really care about, but yeah, if I'm trying to set up a factoring problem, I want to pick the side where my x squared can be positive. If I don't see an x squared positive, I can just always distribute everything through with a negative to force that x squared positive. Okay, so now factor, multiplies to be 15, adds to be -8. Solve for x, I get x equals 5, x equals 3. Let's double check. These should be fine. Is 5 and 3? Oh, actually, is 3 going to give us an issue? Okay, so you see that 3 minus 3 equals 0. Log can only handle positive numbers. It can't handle, I can't have log of a negative number or 0. So that 3, if it causes any issues with any of your original terms, we have to remove it. So that 3 is a little sneaky. It's not negative, but it is 0. So if it causes any issues with any one of them, we have to remove it. Even if it works for the other ones, if it fails for even for one thing, we can't have it as a solution. But 5 is fine. 5 works here, 5 works here, 5 works here. Can't be 0 or negative. Yeah, can only whatever is inside the log has to turn out to be only a positive value. Okay. Okay, everything here is log base what? E, log base E. Now, if that 1 wasn't there, we can just take natural log out, but we may have to do some rearranging here. Yeah, we could do it. We could do it that way. I didn't think about that. I think that will work. I'll work that option out on the board. But I want us to think about another way. Is there another way? What if we put the natural logs on the same side? What if I move this 2x plus 3 to the left side here? Okay, so now I can use my condensing properties. So natural log of A minus natural log of B is the same thing as natural log of A over B. Natural log is really, so this is, I want to solve for x. X is stuck inside that natural log. What's my base here? My base E. Okay, so exponential form, what's my exponential form? E to the first power is equal to 0x minus 4 over 2x plus 3. Okay, we're going to cross multiply and solve for x. Let's finish this up tomorrow. Okay, but we got through a good chunk. Tomorrow we'll just continue working on this. We're not going to do anything new tomorrow. Okay. In fact, tomorrow, Wednesday, and Thursday, we're just going to practice these things that we've learned to get really, really comfortable with it. Okay. All right. Come with your phones.
Okay. Yeah, I'd like to be yours, Mark. Can you finish up the problem? Like, sure. Okay. Yeah.
So that'd be the solution.
No, I didn't finish off the problem. Yeah. This is what I would do next. I would cross multiply. Yeah, go ahead.
So I actually had my AP lens exams tomorrow. I just remembered. I do this weekend, when you are Wednesday, morning, or during lunch.
Anytime is good. My AP calculus classes have dropped off, so
Okay.
anytime is fine.
Okay.
Yeah.
Oh, this year. We go to the,
Yeah, go ahead. Me too. This is the way that you were mentioning. This works as well. 4/7 to natural log of E. You can do any of the combination of log properties. But here, yeah, I can combine these together, drop off the natural log and the algebraic to get the same answer as well.
which one do you recommend?
There's multiple ways, whichever, as long as you can find a connection, I don't know if there's one way that's easier than another. But either way, you're gonna have to manipulate some things to get this work, this to work.
So,
Mhm.
I'm sorry,
Go ahead, go ahead.
check our answer for that, like, make sure it fits, like, I would, like,
I would get this down to a decimal value and then plug that decimal value in for the x's and make sure that it's not causing any parentheses to turn into a
I think a
negative.
negative number when I, like, my calculator, so I think that would work, right? Is that times a negative and then it's.
You're right, yeah, this ends up being negative 4.988.
Right.
And any of these numbers don't work, yeah, so this ends up being a solution.
So you distribute the E among like each term. When you do the cross multiply. So you do 2xe plus 3. So that makes sense.
So what I did was I rearranged the terms, I put the x's together. And then put the non-x's right together. So I can factor the x out like solve for x.
Oh, is that why you like separate them?
Yeah. Remember, e is just a number, so
Okay.
don't treat e like a variable. Treat
Okay.
e as a number, it's just a,
Yeah, that's.
a rational number.
Okay,
Yeah.
thank you.
Just not. But I feel like we're really good with these.
It's just like the polarity is allowed for.
Especially that's like, oh, which one is more, whatever the other case was,